We're starting with example 5 in the notes. So same thing that we were doing yesterday with these problems. We are given a system with one quadratic equation, which is going to be our first one here, and one linear equation, which is our second one. And we want to try to find this, the answers algebraically. So it says to make both equations in the y equals format. You can do that for both if you want, but usually one's already going to be set up as a y equals so that you can take that equals stuff and plug it in for y in the other equation. So that's what we're going to be doing on this first one, is just straight up substitution. There we go. So x plus 2 in for the y is equal to 1/2 x squared plus 3. Now from here, once we do substitution, we've got ourselves a quadratic, and our goal is we want that a value to remain positive. So currently it's positive, so that means we're going to slide everybody to the right side to keep everything positive. So minus x, and then minus 2. And once we have that in standard form equal to 0, the goal is to try to factor it. Now, I don't know about you, but what's making you feel a bit uneasy about this quadratic? That fraction, have we ever factored with a fraction before? No, and you know what? We're not going to. So when I see that fraction, I say, let's go ahead and get rid of it. How do I get rid of the fraction part, or the dividing by 2? We multiply by 2. So I'm going to multiply the entire equation by 2 to get rid of the fraction. If you're like, whoa, wait, we can do that? If I have a balanced equation, I multiply this by 2, we multiply that by 2. Everything stays in balance. So it's a totally legal thing to do, and we're manipulating it so that we don't have to try to factor it with a fraction. So what's 2 times 0? Still 0. And then 1/2 of 2 is 1. So now we have 1x squared, or just x squared. Then we have negative 2x. And we have positive 2. Woo! And now this quadratic looks a whole lot better, or easier to try to factor. Bless you. So we're looking for a product of 2 and a sum of negative 2. Dun, 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 dun. Can we factor that? Oh, no. So what do we do for solving if we can't factor? The quadratic formula. So again, even in these problems, we can encounter the quadratic formula. Sometimes we'll be able to factor, sometimes we won't. And folks, if I can't factor, that is an indication that my roots are either irrational, nasty little square roots, or that they are imaginary. So let's go ahead and go to our calculator and just see what this system looks like. If I type in that first equation, 1/2 x squared plus 3, and then the second equation is x plus 2. There's my quadratic. There's the line. Oh, and it just misses it. So are they intersecting? No. So that means the solutions to this system are going to be imaginary. So that's kind of a nice thing to keep in mind. And one way you can use your calculator to check yourselves on these. So let's go ahead and use the quadratic formula. And I'm just going to put a note that says we can't factor. Can't factor. Here. So QF for quadratic formula. X equals negative b, negative 2, plus or minus the square root of b squared minus 4ac all over 2a. So 2 times 1. So folks, I will say that on the test, the simplifying the quadratic formula is probably one of the more challenging parts. So again, if you're planning on doing a retake on that, please tune in because this is important and it's going to come back to haunt us in this unit as well. We start by finding the discriminant or simplifying under the square root. Notice that these parentheses are important because when I square -2, we get 4. So you can either type that in as parentheses -2 square, or you can just type in the number 4, and then minus 4 times 1 times 2. I want everyone to try typing that in, because again, if you can't type it in on your calculator correctly, that could be why you had some issues on the test. And you should get a number between 0 and -10. If you are not getting a number between 0 and -10, flag me down. -4. Excellent. So then we've got x equals +2. The double negatives become a positive. And then plus or minus the square root of -4 over 2. Now, some people had issues once we got to this step. Folks, can I divide -4 under a radical by 2? No. You find the discriminant first, then you simplify the square root first. Folks, what is the square root of a negative? I. Anytime you have a negative under the square root, that is automatically going to come out as an I. What's the square root of 4? 4 is a perfect square, so it is just 2. So, let's squeeze in that 2 in front of the I. That looks awful. Let's try that again. 2 plus or minus 2I. And then this is all over 2. So then I use division distribution, and I can cancel those out to get 1 plus or minus I. Now, remember yesterday, when we solved by factoring, we found the 2x parts of the coordinate, which is exactly what we found here as well. I just found the possibilities for x. What am I also going to need to find? The possibilities for y. So folks, what I am going to do is I am going to break this down into the plus case and the minus case. Now, in the last unit, we never did that with imaginary solutions because it's like, well, you're not going to actually be able to add those. 1 plus I, can't actually add those together. 1 minus I, can't add those together either. But I think writing the separate x parts of the coordinate out separately makes it a little bit easier for the next step when we try to find out what y is. So if I'm going to plug those imaginary things, oh boy, if I'm going to plug those back into an equation, which one is looking easier? That quadratic one with the squared or the friendly little linear equation? Oh, let's go to that linear equation. So for the linear equation, we are going to have y equals the stuff I got for x, which is 1 plus I, and then plus 2. And then for this one, we'll have y equals the stuff I got for x, 1 minus I, and then plus 2. I'm going to pause for a moment. We're going to rewind back to what we did here. We used the quadratic formula, simplified it, and that gave me the 2x parts of my coordinates. X equals 1 plus I, x equals 1 minus I. Just like in this problem, I got the 2x values. Once I had those x values, I had to plug them back in to find the 2 corresponding y values for those coordinates. So I chose to plug these nasty little complex numbers into that linear equation to find the corresponding y values. Now, my y values are also going to be complex. And what we need to do is simplify those expressions. Remember, in complex form, the real stuff always goes first. The imaginary part goes second. There's my first y value. Then for this one, I've got positive 1 plus 2. So y equals 3 minus I. Real part first, imaginary part second. So my solutions, my coordinates, are going to be 1 plus I, 3 plus I, and 1 minus I, and 3 minus I. So it's a little bit strange, but we are finding the full imaginary coordinates, even though we wouldn't be able to graph them. So we could say about this one that there are no real solutions. So no real solutions. So significantly harder than what we did yesterday? Yeah. Is it going to come up all the time? No. Just for the imaginary ones, but that's why checking yourself on your calculator and kind of getting a gist of what you're trying to get to is a good idea on these problems. Folks, that concludes the assessed part of the notes. Remember, these applications are optional. If you try it on the test, I will grade it and I will put the score in. If you don't try it on the test, I will not grade it and it is exempt. Miss Yassi's videos are posted on today's daily pacing under today's date. So if you want to watch them and learn them, you certainly can. You've got all the homework practice problems you can try as well. But otherwise, I would focus on the 2 that are also graded. So folks, that concludes the notes. So now we're going to go into the guided practice.